Hi everyone, welcome back to Water Supply Engineering with the module of Water Distribution System. And this time we will discuss on water conveyance and pumping. So the objective of water conveyance is to provide a conduit to pump water from raw water intake to the treatment plant and from the treatment plant to the point of use. There are two types of the conveyance system. Yeah, one of which is open channel. Open channel is usually used to deliver water in a channel, flume, or adequate. And then the other one is pressure conduit. And in this water conveyance system, usually we just use the pressure conduit. So what we have to consider in this uh, water conveyance is the hydraulic consideration. Yeah. So usually for the open channel, we use the Manning equation to determine the flow rate. Yeah. So the flow rate is Q here, uh, depend by the surface area of the channel, and then also the hydraulic radius R, and also the loss of head loss in the channel over length, S. So similar to the pressure conduit, yeah, but in this regard we apply Hazen-Williams equation. So to determine the velocity of the water inside the conduit, it depends on the constant and then multiple by also called Hazen-Williams equation, uh, Hazen-Williams constant, and then also determined by this hydraulic radius and also the head loss over length of conduit. So in US customary unit, yeah, in which the unit is used in the length is in feet, and then the the time measure is in second. Yeah. So the equation is like this. Yeah. So V equal 1.32 multiplied by CH. CH is Hazen-Williams constant, multiplied by R power 0.63, and then multiplied by S power 0.54. Yeah. So we can see the explanation of the V is the velocity, and then the CH is Hazen-Williams coefficient, R is hydraulic radius, and then S is the ratio of head loss over length, yeah, HL over L. And then in this hydraulic consideration, the value of Hazen-Williams coefficient only determined by the condition of surface of the pipe or conduit. Yeah. So normally it is written in one table. So for instance here, we have type of material. Let's say we take for steel or ductile iron or cast iron with centrifugally applied cement or bituminous lining. Yeah, the value for the average for new clean pipe is 150, but for the design value, usually we take the lower value. Yeah. So similar to other type of pipe, yeah, let's say concrete. Yeah, concrete. For the new pipe, the value is 120, and the design value is 100. Similar also to steel, cast iron, and uncoated. Yeah, the average value 130, and the design value is 100. So similarly in the SI unit, yeah, the equation, uh, the coefficient is different, yeah, because the unit is used here is different. So that's why the equation of velocity equal 0.85 multiplied by CH multiplied by R power 0.63 multiplied by S power 54. So here the velocity is in meter over second. Yeah, and then the Q is A multiplied by V. Okay, other calculation are often desired. Yeah, usually if we require to determine the size of pipe. Yeah, if we are going to determine the size of pipe, yeah, so we must be given the flow rate and the energy loss. Yeah, so we can determine this size of pipe. Similarly, if you are going to determine the energy loss, we should have the information on flow rate and also the length of pipe or the type of and size of pipe. So the following table shows several forms of the Hazen-Williams formulas. You can see here, let's say, if you are going to determine the velocity, yeah, the velocity in US customary unit, yeah, we use this formula. Yeah, we use this formula. Uh, Velocity in SI unit, yeah, we use this formula. So similarly, for other parameters such as Q, we are going to determine Q. We apply this formula. Yeah. So this one is in US customary unit. For the SI unit, we use this formula. Yeah. So similarly, for the head loss and also diameter, yeah, can be determined by using the Hazen-Williams equation in different form. Okay, and then we can see also the unit. Yeah? The unit is different because in US customary unit for length we use feet, and then for weight we use pound, and in SI unit normally for length we use meter and for weight in kilogram. Okay, to determine uh, the size of pipe, we need to know the head loss and also the velocity. Yeah. So similarly, if you are going to determine the velocity, we need to know the head loss and diameter. Yeah. So for this calculation, can be used the nomograph, yeah, for the hydraulic calculation. However, in this nomograph, the Hazen-Williams coefficient value is only applied for 100. Yeah? So that's why here, if we have to determine the velocity, the flow rate, the velocity, the flow rate, yeah, diameter, and the head loss in other CH value, we have to multiple by a correction factor like this. Okay, this is the example of nomograph. Yeah, so this nomograph, yeah, actually we can determine here we have the flow rate in cubic meter over second. We have diameter pipe in millimeter, and then we have the head loss in meter over 1,000 kilometer, and then also the velocity in meter over second. Yeah? So if given the head loss here, and then the diameter is here, so we can directly draw the straight line, yeah, to determine the volume flow rate here and also the velocity here, yeah. So simply can do like that. So here, for instance, at this point, yeah, the head loss in this point, and then we have the diameter at this point. So we can draw the straight line, yeah, from these 2 points, and then we can determine here the velocity, and also here for the flow rate. Here the velocity, and here is the flow rate. Yeah. So much more easier to use the nomograph. Yeah. Okay. All right. Now we go through the topic of water pumping. Yeah. In this water pumping, we use the general energy equation. Yeah. Which is derived from Bernoulli equation. Yeah. So actually here we have the head loss. Yeah, in actual head loss is determined by the pressure head, yeah, and then velocity head. Elevation head. Yeah, this one is elevation head and velocity head, plus also the head loss inside the pipe by friction. Yeah. So finally, we should determine the power required. Yeah, to determine the power required for the fluid pump. Yeah, in which here we apply the formula. The power PA equal to HA. HA is the total head loss multiplied by gamma, which is the specific volume, and then multiplied by flow rate Q. Okay, regarding the type of pipe, we can divide it into majorly into two type of pump. Yeah, uh, the first one is positive displacement pump, and the second one is the kinetic pump. Yeah, so usually we use in the common pump used in the water distribution system is a centrifugal pump. Yeah. However, there are many other pump also used. Yeah. But we focus on one example here, how the centrifugal pump works. Okay. This is the example of the kinetic pump, which is what to say, specifically we call it as a centrifugal pump. Yeah. So the water flows through this, what to say, inlet, and then go out through this outlet. So this is some figures of other pumps. Yeah, we will go through here. And what is the important performance evaluation for the centrifugal pump? Yeah, actually this one we can get the performance data from the manufacturer. Yeah, so usually the manufacturer will provide the performance of centrifugal pump based on pump capacity and also the total heads. Yeah, so from this correlation, let's say we have the pump with the capacity of 4,000 liter over minute. Yeah, so we can draw the straight line here until this point. So we get the total head is here. Yeah, total head here, around 140. And then similarly, other than correlation between flow rate and total head, yeah, we get also the correlation between the flow rate and the efficiency of pump. Yeah. So similarly, to determine the efficiency, for instance, the pump capacity is here. The efficiency is what to say here. Yeah. Okay. So this is the example. Let's say we have 1,500 gallon of minute per minute of pump. We get the total head here is around 137. Yeah. And then if we have the pump with 1,500 gallon per minute of the capacity, so we'll obtain here, we can determine the power here. Yeah. So around 37 kilowatt. Okay, for the net positive suction head required, yeah, the manufacturer also provide, yeah, the specific data. So for instance here, if we have the pump with 200 250 gallon per minute, yeah, so we can get here the net positive suction head. Yeah, you can see here 5 feet, 6 feet, 7 feet, and 8 feet. So at this point is around 7.6 or 7.7 like this. Yeah. Oh, sorry, here. Okay. So this is the way how we determine some uh, parameters if two parameters is given here. Yeah. So the complicated one is composite performance chart. Yeah. This one is uh, the charts that determine the performance efficiency of the pump in correlation with net positive suction head, yeah, and then power requirement, the capacity, and also the total head. Yeah. So I think this all for the water conveyance and pumping. Thank you for your participation in this class. And now I will stop the presentation. Thank you.